Hi, in this video I will show you how to add how to analyze an image, an antibiogram image, and add it to an experiment. So here we have just started AntibiogramJ, we have our user, we select it. Now we open the experiment that we created before, this one, and now we are going to add an antibiogram to this experiment. So we go to this button, press it, and then we select the image that we want to analyze. Okay, here we are. So here you can see an image that has been captured with a digital camera device. So we have a wizard that guides us to provide the necessary information. So the first thing that we have to do is introduce the data about the bacteria that we are studying. So we have to provide the family, the genus, Ikia. This is an E. coli, and the strain number is 785. And then we press next. So as I have said, this image has been captured using a digital camera device. So you can use a digital camera or a mobile phone. And one of the problems is that it might be a high variability among these images. So we can adjust the quality of those images in this second step, image preprocessing. So the first step consists in cropping the image to just keep the plate. So there are two options for this. We can ask the system to automatically select the region to crop, just pressing this button. This detects the region, and as you can see, a circle is around the display. We just can move it, or we can increase the size, and then once that we are happy, we press the crop button, and we just keep the plate as the main image. We can also undo this, and we can select manually the region. Just we press on with the right button, with the left button, sorry, and select the region to crop, and finally press the crop button. Okay, this is as you prefer. Now we press the next button, and the next step allows us to adjust the contrast and brightness of the image. So we can apply an automatic adjustment pressing this button. You can see the quality of the image is better now. We can reset this, and we can also adjust the brightness and contrast manually. Okay, so we can play with these values if we want. Okay, and we'll just keep it as it was at the beginning. So now we press the next button, and we ask the system to detect the different circles, the different antibiotic discs. So as you can see, 7 discs has been detected, the 7 discs of the image. We can modify them if we are not happy with the selection. Stands this one. We can also move it. If we are not happy with one of them, we can just press it and then press the delete this button. And if some of the disc is missing, we can draw a circle and then press the add this button. Okay, and we can just remove it just pressing the delete key of the keyboard. Here we can also change the colors, the ones that you prefer. Okay. So now that we have finished this edition, okay, let's finish this one. Okay. Now we just press the next button, and we have to provide the size of one of these discs in millimeters. As I have said previously, this image can be captured using a mobile phone, a camera device. So the length of those images, of those digital cameras, is different. So we need this value to calibrate the image. So usually the size of this disc is 6 millimeters, but you can change it. So in this case, it's okay. And here we have that the system reads the antibiotic list. Well, if you read our paper, you will see that this reading is made by a learning system. So the first time that the learning system tries to read this antibiotic list, it is not able to read anything, well, because it hasn't learned anything yet. But the next time that we will use it, the system will have learned this the names, the codes written in this list, and it will be able to read them. So in this case, we have to provide manually the list. So we have the labels. One corresponds with this one, and so on. So here we have the different families of antibiotics. This time we go to penicillins and select the ampicillin. This one. Okay, we go to the second. And we select the correct one. Okay. This one. And so on. So this might take some time at the beginning, but the next time that you will use it, the system will have learned all these names, so you will not have to provide them manually. Okay. So let me just finish this. So this one, number 5 is tefoxetine. Okay, so and so on. Princeton. And 7 is this one. Oh. Okay, so well, as you can see, the first time it might take some time, but the next time that you use it, the system will have learned all these codes. So now we press the next button. In the case that there is some restriction in the breakpoints provided by EUCAS, you will have to select the correct antibiotic option. For instance, we have here to select between amoxicillin clavulanic acid or the second option. So we just select the first one. And now the system automatically detects the ALOS inhibition zones. Okay, so here we have. So we have that in this image we have the detection, the yellow circle indicates the detection zone that had been detected by the program. As you can see, well, it's correct, the detection. And here the red circle indicates the limit for the resistance size. So the limit for the resistance size of this antibiotic is, for this family, is 14 millimeters. This is indicated here, but also it's indicated here. So you can easily visualize that this antibiotic is resistant. And now we can visit the rest of them. So for instance, there is not a breakpoint available for this antibiotic, so this is indicated, but we have the size. For this one, well, we can easily see that this is susceptible. For this one, obviously it's resistant. For this one, well, we can play a bit, and so on. So here there is a special case. So we have up to now just the red circle and the blue circle, the red circle and the yellow circle, sorry. Now we have a blue circle. This indicates the limits for the susceptibility point. So while this region was not correctly detected, we can fix it just here. But let me show you that, well, you can see here that it's resistant. But if we edit the allo size, just moving this slider up to this point, between the blue and red circle, the category automatically changes. And we can continue, and this will be susceptible. And we can also manually fix the size, and this is drawn automatically, and the category is automatically computed. And here, for instance, we have colonies. So, well, we can annotate this and give an interpretation. And finally, we have this, that where there is no information about for this case, but we have the allo size. So we press the next button, and here we can edit the image. Well, we can edit each antibiotic one by one. We can provide the category and the diameter and change the size. We can show the diameter or the radius, change the alignment, you can see here. And we can use the same configuration for all the antibiotics. You can see here. Okay, you can also change the color. What you can play a bit. So this is for presentation purposes. And then we press the finish button. The image has been analyzed. And here we go back to the main window. And you can see that our experiment that up to now was empty, it has now a new experiment, this E. coli. So here you can see the information of all the antibiograms that has been added to the experiment. So we have here the information about the antibiotic, the code, the category, and so on, the diameter, so on. And if we press on this antibiogram, we can see a summary of the antibiogram. You can see here the image, the information about the bacteria, and also antibiotics. And also you can see the annotations. Okay, and save the image. And up to here, the explanation about how to analyze an image and add it to an experiment.